Yes, refrigerators and freezers are considered kitchen equipment under the rules of Article 220.56 of the National Electrical Code 2005, specifically concerning kitchen equipment other than dwelling units. This article outlines the demand factors that shall be applied to all equipment that has either thermostatic control or intermittent use as kitchen equipment. Understanding these demand factors is crucial for accurately calculating the electrical load requirements for commercial kitchens and similar installations. The purpose of demand factors is to account for the fact that not all kitchen equipment will be operating at its maximum rated load simultaneously. This allows for a more efficient and cost-effective design of the electrical system. Applying the correct demand factors prevents oversizing the service and distribution equipment while still ensuring that the electrical system can safely and reliably handle the actual load imposed by the kitchen equipment. To properly apply Article 220.56, several steps must be taken. Firstly, identify all kitchen equipment that falls under the scope of the article, meaning equipment other than dwelling units that has either thermostatic control or intermittent use. This includes, but is not limited to, refrigerators, freezers, ovens, dishwashers, and various cooking appliances. Secondly, determine the connected load of each piece of equipment in voltamps or watts. The connected load is the total power consumed by the equipment when it is operating at its maximum capacity. This information can typically be found on the equipment's nameplate or in the manufacturer's specifications. Thirdly, apply the appropriate demand factors from Article 220.56 to the connected load of each piece of equipment. The demand factors are expressed as percentages and represent the fraction of the connected load that is expected to be in use simultaneously. The specific demand factors to be used will depend on the number and type of kitchen equipment being considered. For example, the NEC may specify different demand factors for ranges, ovens, and other cooking appliances compared to refrigerators and freezers. Fourthly, sum the demand loads of all the kitchen equipment to determine the total demand load for the kitchen. This is the amount of power that the electrical system must be capable of supplying. Fifthly, verify that the electrical system, including the service entrance, feeders, and branch circuits, is adequately sized to handle the total demand load. This involves performing calculations to ensure that the conductors and overcurrent protection devices are properly sized in accordance with the NEC requirements. In many cases, the NEC provides tables and guidelines for determining the minimum conductor size and overcurrent protection device rating for various types of loads. It's important to consult these resources to ensure compliance with the code. Let's consider a practical example to illustrate the application of Article 220.56. Suppose we have a commercial kitchen with the following equipment: 1. A refrigerator with a connected load of 1200 volt amps. 2. A freezer with a connected load of 1500 volt amps. 3. An oven with a connected load of 5000 volt amps. 4. A dishwasher with a connected load of 3000 volt amps. And 5. Various other small appliances with a combined connected load of 2000 volt amps. To determine the total demand load for the kitchen, we need to apply the appropriate demand factors to each piece of equipment. Let's assume that the NEC specifies the following demand factors for this type of kitchen: 1. Refrigerators and freezers 70%, 2. Ovens 65%, 3. Dishwasher 60%, and 4. Other small appliances 50%. Applying these demand factors to the connected loads, we get the following demand loads: 1. Refrigerator 1200 volt amps times 0.70 equals 840 volt amps. 2. Freezer 1500 volt amps times 0.70 equals 1050 volt amps. 3. Oven 5000 volt amps times 0.65 equals 3250 volt amps. 4. Dishwasher 3000 volt amps times 0.60 equals 1800 volt amps. And 5. Other small appliances 2000 volt amps times 0.50 equals 1000 volt amps. Summing these demand loads, we get a total demand load of 840 volt amps plus 1050 volt amps plus 3250 volt amps plus 1800 volt amps plus 1000 volt amps equals 7940 volt amps. This means that the electrical system for the kitchen must be capable of supplying at least 7940 volt amps. Based on this total demand load, the appropriate size conductors and overcurrent protection devices can be selected to ensure that the electrical system is safe and compliant with the NEC. It's important to note that the specific demand factors and requirements of Article 220.56 may vary depending on the specific edition of the NEC that is in effect. Therefore, it's always essential to consult the latest edition of the NEC and any applicable local amendments to ensure compliance. Furthermore, it's recommended to consult with a qualified electrical engineer or contractor to ensure that the electrical system for a commercial kitchen is properly designed and installed. These professionals have the expertise and experience to navigate the complex requirements of the NEC and ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. In addition to the demand factors specified in Article 220.56, there may be other factors that need to be considered when calculating the electrical load for a commercial kitchen. These factors may include the diversity of the load, the operating schedule of the equipment, and the potential for future expansion. The diversity of the load refers to the extent to which the various pieces of equipment are likely to be used simultaneously. If the equipment is used in a coordinated manner, such that only a few pieces of equipment are operating at any given time, then a lower demand factor may be appropriate. The operating schedule of the equipment refers to the times of day and days of the week that the equipment is likely to be used. If the equipment is only used during certain hours or on certain days, then a lower demand factor may be appropriate. The potential for future expansion refers to the possibility that the kitchen may be expanded or that new equipment may be added in the future. If there is a reasonable possibility of future expansion, then it's important to factor this into the electrical load calculations to ensure that the electrical system is adequately sized to handle the increased load. To accurately account for these factors, it may be necessary to conduct a load study or to consult with a qualified electrical engineer or contractor. A load study involves measuring the actual power consumption of the kitchen equipment over a period of time to determine the actual demand load. This information can then be used to refine the demand factors and ensure that the electrical system is properly sized. In summary, Article 220.56 of the National Electrical Code 2005 provides specific guidelines for calculating the electrical load requirements for kitchen equipment other than dwelling units. This article specifies demand factors that shall be applied to all equipment that has either thermostatic control or intermittent use. By properly applying these demand factors and considering other relevant factors, it's possible to design an electrical system that is safe, reliable, and compliant with all applicable codes and standards. Remember to consult with the latest edition of the NEC and with qualified professionals to ensure compliance and safety. Accurate electrical load calculations are essential for preventing overloads, voltage drops, and other electrical hazards. A well-designed electrical system will ensure that the kitchen equipment operates efficiently and reliably, contributing to the overall success of the commercial kitchen operation. Remember that local codes and regulations may have additional requirements or amendments to the NEC. Always consult with local authorities to ensure full compliance. The NEC serves as a comprehensive guideline, but local jurisdictions may have specific modifications based on regional needs and safety concerns. Thoroughly understanding and adhering to these local requirements is crucial for ensuring a safe and code-compliant electrical installation. Furthermore, keep in mind that the electrical industry is constantly evolving, with new technologies and best practices emerging regularly. Staying up to date with the latest advancements is essential for electrical professionals to provide the best possible service to their clients. This includes attending industry conferences, participating in continuing education courses, and reading trade publications. Continuous learning is key to maintaining expertise and ensuring that electrical installations are performed safely and efficiently. When working with electrical systems, safety should always be the top priority. Electrical hazards can be deadly, so it's crucial to follow all safety precautions and use appropriate personal protective equipment. This includes wearing safety glasses, gloves, and other protective gear as needed. It's also important to energize circuits before working on them and to verify that they are energized using a voltage tester. Never take shortcuts or compromise on safety when working with electricity. A moment of carelessness can have devastating consequences. If you're not comfortable working with electricity, it's best to call a qualified electrician. These professionals have the training, experience, and equipment to perform electrical work safely and effectively. Attempting to do electrical work yourself without the proper knowledge and skills can be extremely dangerous. Always prioritize safety and seek professional help when needed. In conclusion, understanding and applying Article 220.56 of the NEC is essential for anyone involved in the design, installation, or inspection of electrical systems for commercial kitchens. This article provides specific guidelines for calculating the electrical load requirements for kitchen equipment, ensuring that the electrical system is adequately sized to handle the load. By following these guidelines and consulting with qualified professionals, it's possible to create a safe, reliable, and code-compliant electrical system for any commercial kitchen. Remember to stay up to date with the latest edition of the NEC and any applicable local amendments, and always prioritize safety when working with electricity. The NEC Article 220.56 is not a standalone provision. It must be read and applied in conjunction with other relevant articles of the NEC. For instance, Article 210 covers branch circuits, Article 215 covers feeders, and Article 230 covers services. These articles provide additional requirements for the installation of electrical systems, including conductor sizing, overcurrent protection, and grounding. It's essential to have a comprehensive understanding of these articles to ensure that the electrical system is properly installed and meets all applicable code requirements. Another important consideration when applying Article 220.56 is the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or fail to operate properly. The NEC specifies maximum allowable voltage drop for various types of circuits. It's important to calculate the voltage drop for all circuits in the electrical system and to ensure that it does not exceed the allowable limit. To minimize voltage drop, it may be necessary to use larger conductors or to install additional voltage drop compensation devices. Grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit. The NEC specifies detailed requirements for grounding electrical systems. It's essential to follow these requirements carefully to ensure that the electrical system is properly grounded and that the risk of electrical shock is minimized. Surge protection is also an important consideration, especially in areas that are prone to lightning strikes or power surges. Surge protection devices protect sensitive electronic equipment from damage caused by voltage spikes. The NEC recommends the use of surge protection devices in certain applications. It's important to assess the risk of surges and to install surge protection devices as needed to protect valuable equipment. Regular maintenance and inspection are essential for ensuring the continued safety and reliability of electrical systems. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. Maintenance tasks such as tightening connections, replacing worn parts, and cleaning equipment should be performed on a regular basis. Proper maintenance and inspection can help to prevent electrical failures and extend the life of the electrical system. Furthermore, documentation is crucial for the efficient management and maintenance of electrical systems. Accurate and up-to-date documentation should be maintained for all electrical systems, including wiring diagrams, equipment specifications, and maintenance records. This documentation can be invaluable for troubleshooting problems, performing maintenance, and making future modifications to the electrical system. In the context of energy efficiency, applying Article 220.56 correctly can lead to significant energy savings. By accurately calculating the demand load for kitchen equipment, it's possible to avoid oversizing the electrical system, which can reduce energy consumption and lower utility bills. Energy-efficient equipment should also be considered when designing or upgrading a commercial kitchen. Energy-efficient refrigerators, freezers, ovens, and other appliances can significantly reduce energy consumption and lower operating costs. Rebates and incentives may be available for installing energy-efficient equipment. Sustainable design practices should also be incorporated into the design of commercial kitchens. This includes using sustainable materials, minimizing waste, and conserving water. Sustainable design can help to reduce the environmental impact of the kitchen and create a healthier and more comfortable environment for employees and customers. In conclusion, the application of Article 220.56 involves a multifaceted approach that encompasses code compliance, safety, energy efficiency, and sustainable design practices. By carefully considering all of these factors, it's possible to create a commercial kitchen that is not only safe and reliable, but also energy efficient and environmentally responsible.